You know less about the ocean beneath your feet than the surface of Mars. While cities bustle above, below, 90% of all life-sustaining carbon drifts down as a silent snow. And every night, the largest animal migration on Earth unfolds just out of sight. Yet these waters rewrite every rule we thought we knew about life, survival, and darkness. Why is the world's greatest wilderness still so utterly alien? And what secrets wait as we begin the descent? At 200 meters beneath the waves, sunlight weakens until it finally disappears. Here in the ocean's twilight zone, life depends on a quiet phenomenon few ever imagine: a slow, constant rain of particles drifting down from above. This is marine snow. Each flake is a bundle of dead plankton, bacteria, fecal pellets, and organic fragments, falling through the dim blue like a silent blizzard. What looks like emptiness is, in truth, a conveyor belt of nourishment. Every year, billions of tons of carbon and nutrients descend from the surface, feeding creatures that will never see the sun. Scientists estimate that nearly 90% of the carbon captured by ocean life is sent downward in this way. Without this invisible snow, the deep would be a desert. The journey of each particle is perilous. Most are devoured long before reaching the seafloor. Hungry mouths, jellyfish, worms, and strange transparent fish wait in the darkness, snatching what they can. Only a fraction of the snow escapes this gauntlet, carrying the memory of sunlight deeper still. This process is so efficient that the twilight zone acts as the ocean's beating heart, pumping energy to every layer below. Dr. Edith Widder, who has spent decades exploring these depths, describes the marine snow as the lifeblood of the deep. She says it is the currency of survival. Every flake is a chance for life to continue where sunlight cannot reach. The twilight zone is not empty. It is teeming with life shaped by hunger, patience, and the endless fall of nutrients. Each night, the rules of survival change as the darkness stirs and the world's largest migration begins. But for every creature that rises, countless others remain, waiting in the blue gloom, sustained by the snow that never stops falling. Every night, as the sun sets, the twilight zone comes alive with movement on a scale that dwarfs anything seen on land. Billions of fish, shrimp, and squid rise toward the surface in a silent, synchronized ascent. This nightly journey is called DL vertical migration, and it is the largest animal migration on Earth. Creatures leave the safety of the deep to feed under cover of darkness, then retreat at dawn to avoid becoming prey themselves. Lanternfish, bristlemouths, and glass squid, all nearly invisible in the dim light, form vast, shifting layers that can stretch for hundreds of kilometers. During World War II, Navy sonar operators searching for enemy submarines stumbled upon something baffling. Their instruments detected what looked like a second seafloor, a mysterious false bottom that hovered hundreds of meters above the real ocean floor. This phantom layer moved up each night and sank as the sun returned. Scientists later realized they were watching the migration in action, an entire ecosystem on the move, so dense it bounced back sound waves like solid ground. Predators and prey play a deadly game in these twilight waters. Some fish have bellies lined with tiny lights, matching the faint glow from above to erase their own shadows, a trick known as counter-illumination. Others use the darkness as camouflage, waiting for the unwary to rise. The rules change with every meter descended. For the animals that make this journey, survival means staying one step ahead of both hunger and being hunted. This nightly pulse of life drives the ocean's food web, cycling nutrients between surface and depths. Yet, as darkness thickens, fewer creatures dare to venture further. Below, a new realm awaits, one where sunlight never reaches, and the dangers are written not in shadow, but in total, eternal night. Below 1,000 meters, the ocean transforms into a world of constant cold and crushing pressure. The darkness here is absolute. No sunlight, only the faintest blue haze from bioluminescent flashes. The water hovers around 4 degrees Celsius, and the weight above presses down at more than 100 times what we feel at sea level. In this realm, hunting is a game of senses, not sight. Most creatures are nearly blind, their eyes tuned to catch the briefest glimmer of movement or glow. But some have mastered the art of ambush. The dragonfish, for example, drifts in the blackness, its long, needle-like teeth invisible until it strikes. Unlike most deep-sea predators, the dragonfish wields a secret weapon. It can produce red light from a patch beneath its eyes. Down here, red light is as good as invisible. Almost nothing can see it. The dragonfish uses this invisible beam like a sniper's scope, scanning for prey that cannot detect its approach. When a shrimp or small fish drifts into range, the dragonfish lunges, jaws snapping shut with surgical precision. Its prey never sees the attack coming. Other hunters rely on touch and vibration. Some fish grow long, trailing filaments that sense the faintest ripple in the water, signaling the approach of a meal or a threat. In the perpetual night, every advantage is a matter of life and death. The arms race is relentless. Sharper teeth, more sensitive eyes, stranger lights. Even the pressure itself shapes these animals. Bodies are soft, boneless, built to withstand forces that would crush a human in seconds. The creatures here do not just survive, they thrive by turning the darkness and pressure into weapons. This is a world where nothing is wasted. Every movement, every adaptation is honed by millions of years of silent conflict. The ocean's midnight zone is not empty. It is a battleground, fought in the dark by hunters armed with senses beyond our imagination. At nearly 2,500 meters down, the ocean becomes a place where familiar rules break apart. Here, in the pitch black, a remote-operated vehicle glides through the water, its thrusters humming quietly. The pilot, Scott Doherty, sits far above on the surface, eyes locked on the live video feed. Most ROV dives in this region are routine, inspecting pipelines and checking for leaks. But on a day in 2017, during a shell operation in the Gulf of Mexico, something wholly unexpected drifts into view. The creature floats, arms held out like the strings of a marionette, its body nearly transparent. This is the bigfin squid, Magna Pina, an animal so rarely seen alive that only a handful of encounters have ever been recorded. Its arms and tentacles stretch 6 meters or more, trailing behind it like ghostly ribbons. The fins undulate slowly, giving the impression of a parachute caught in a silent current. Doherty later described his heart stopping as the animal hovered in front of the ROV, moving with an eerie, deliberate grace. For a moment, the routine of deep-sea engineering gives way to awe. The ROV's lights, switched to red to avoid spooking the animal, cast a faint, otherworldly glow. In this spectrum, most deep-sea creatures are blind, allowing the camera to capture the bigfin's every movement without disturbing it. The footage ripples through the scientific world and social media alike. People struggle to describe what they are seeing. Alien, prehistoric, impossible. The bigfin's joints bend at right angles, its limbs dangle like wires, and its eyes reflect the faintest glint in the dark. It looks less like a squid and more like something dreamed up for another planet. The encounter lasts only minutes before the squid drifts away, swallowed again by blackness. For Doherty and for anyone watching the footage, the message is clear. The deep ocean is not empty. It hides forms so strange that even seasoned explorers are left speechless. After the big fin vanishes, the ROV resumes its slow patrol, scanning a seafloor that now seems emptier than ever. Emptier but haunted by the memory of what just passed through its lights. The seafloor stretches out for thousands of kilometers, a plain of mud and silence broken only by the occasional ripple of current or the slow drift of a fallen shell. This is the abyssal plain. Here, at depths between 4,000 and 6,000 meters, the ocean reveals its true scale. A world so vast and empty it defies imagination. The temperature hovers just above freezing, between 2 and 4 degrees Celsius. The pressure presses down with a force 400 to 600 times greater than at the surface. Enough to crush a human body in an instant. No sunlight has touched this place for millions of years. The only light comes from the brief, cold flashes of bioluminescence, signals between creatures that might never meet again. Most of the time, there is only darkness and the slow settling of marine snow from above. Food is scarce. The seafloor is coated in a fine ooze, built grain by grain from the remains of plankton, volcanic ash, and dust that have drifted down for eons. In some places, this layer is hundreds of meters thick, a record of the world above written in silt and bone. Patience is the currency of survival. Life here moves at a glacial pace. A single meal might be a scrap of whalebone or a sunken log, discovered after decades of waiting. The animals that endure this desert are shaped by scarcity and time. They cling to rocky outcrops, gather around the faintest whiff of nutrients, and wait. Most of the abyss is empty, a testament to the sheer size of the ocean and the persistence required to survive where almost nothing is given. The abyssal plain is not just a desert of mud and silence. It is home to some of the largest and longest-lived animals on Earth, giants shaped by scarcity, not abundance. The colossal squid, for example, stretches its arms wider than a city bus, yet it survives on the barest trickle of food. Its relatives, the giant amphipods and isopods, grow to the size of dinner plates, their bodies pale and armored, waiting for decades between feasts. Scientists have puzzled over this deep-sea gigantism. In a world where every scrap of food is precious, why do some creatures grow so large? One theory points to efficiency. Large bodies move slowly, conserving energy in the cold, high-pressure dark. They can travel farther in search of food and store nutrients for lean years. Some, like the Greenland shark, live for centuries, their hearts beating just once every 12 seconds. Others, such as the tube worms clustered around hydrothermal vents, can reach lengths of 2 meters and survive on chemical energy alone. Bypassing the need for sunlight or marine snow, every adaptation here is a gamble against time and hunger. Growth is slow, lifespans stretch into the unknown, and reproduction may happen only once in a lifetime. The mystery remains. In a place where almost nothing is given, the ocean has built its secrets on a grand scale. The plain rolls on, empty to the eye, but beneath the silt and silence, giants endure, living reminders that the rules of survival in the deep are written in paradox. 6,000 meters down, the ocean turns hostile in ways that defy imagination. Here, the weight of the water above reaches more than 1,000 times the pressure at the surface. Every square inch is pressed by a force equal to a small car. This is the realm where human-built machines have imploded in seconds, their titanium hulls crumpling like paper. For life, survival means rewriting the rules of biology. Bones, shells, and lungs, the tools that work in shallow water, fail in the Hadal zone. Instead, creatures here are soft, boneless, and filled with fluids that cannot be compressed. Their bodies are built from the inside out to resist the squeeze. But even this is not enough. At these depths, ordinary proteins begin to unravel, their delicate shapes warped by relentless pressure. Cells risk collapse. Enzymes stop working. Yet somehow, life persists. The secret lies in chemistry. Deep-sea fish and invertebrates fill their cells with a compound called trimethylamine N-oxide, or TMAO. This molecule acts as a molecular brace, locking proteins into shape and preventing them from folding under pressure. The deeper the animal lives, the more TMAO it carries. Its blood thickens, and its flesh takes on a salty, almost bitter taste. Scientists have found that at the greatest depths, TMAO levels reach their peak, setting a hard limit for how far vertebrates can descend. The Hadal trenches are not just cold and dark, they are a crucible, where only the most extreme adaptations can hold back the crushing weight. Here, physics is the first and last law. Life endures, not by defying pressure, but by surrendering to it and becoming something altogether new. January 1960, the bathyscaphe Trieste carried Jacques Piccard and Don Walsh into the deepest known part of the ocean, Challenger Deep. As the submersible slipped below 9,000 meters, a sharp crack echoed through the sphere. One of the outer plexiglass window panes had fractured under the strain. Outside, the pressure was over 14,500 pounds per square inch, nearly 1,000 times what a human feels at sea level. Inside, the two men sat in a steel sphere just large enough to crouch in, breathing air at a gentle 15 pounds per square inch. At that depth, a single flaw meant instant disaster. With the crack spreading, they triggered the emergency ballast system. Tons of iron pellets dropped away, lightening the submersible and slowing its descent. The hull groaned, but held. Minutes later, Trieste reached the bottom, 10,911 meters down, where the pressure outside soared past 16,000 pounds per square inch. While human engineering strained at its limits, life on the seafloor moved as if nothing had happened. Amphipods the size of insects scuttled past the viewport, their bodies untroubled by forces that threatened to crush steel. Nearby, a Hadal snailfish drifted, its tissues braced with natural chemicals that keep cells stable, where human bones would shatter. For Piccard and Walsh, the abyss offered a lesson in humility. The best technology could barely survive a single visit. Yet these fragile-looking animals endure the pressure every moment of their lives. The Trieste's journey stands as a reminder. In the Hadal zone, human ambition is outmatched by the quiet resilience of the creatures that call the deep home. The ocean's greatest depths are not empty. They are simply beyond the reach of most who try to enter. Beneath our ships and satellites, more than 70% of the ocean floor remains unmapped, its depths absorbing everything from carbon to microplastics. As technology finally pierces the abyss, what we discover will reshape biology, climate science, and our place in the universe. The ocean is not a distant frontier. It's the engine of our future. The real mystery is how much longer we can afford to ignore it.